All right. Good morning, everyone, and welcome to the September 2022 Argo CD and Rollouts Community Meeting. I'm your host for today, Jesse, and I am a maintainer of the Argo project. And if you haven't already, please open the Google Doc and add yourself as an attendee list. And just a reminder that the Argo project adheres to the CNCF Code of Conduct. So please be courteous and respectful to each other. And this meeting is being recorded and will be uploaded to YouTube. If you do have any agenda items or issues or discussion topics, you're welcome to add them also to that Google Doc. So for today, we have two things on the agenda. Leo will be covering a new feature in Argo CD that utilizes the Kubernetes server-side apply feature. And Zach will be discussing the open API schemas that actually apply to all Argo projects. Before we get into those, I wanted to remind everyone that ArgoCon is happening in actually less than 2 weeks, and it's not too late to register. So if you haven't already, there's a link in the Google Doc to the information about ArgoCon, and yeah, it's a hybrid event. So if you're in the Bay Area, you can attend in person, but otherwise it's also virtual. Okay, so I think we can move on to the first topic, which is the server-side apply. And Leo, you want to take it?
Hi, everyone. So maybe I can share my screen. This out of the way. And yeah, I prepared a few slides. So basically, new Argo CD 2.5 will ship with support to server-side apply. So we are expecting to cut the first release candidate in a few weeks, and yeah, that RC, the first RC will have this feature available. This is a feature that required changes in GitOps engine as well as in the main Argo CD repo. So if by the time we release RC1, if people find bugs, just fill it the bugs in Argo CD repo issues, and we are going to be handling that properly. So what are the current problems that this proposal try to solve? So first off, the famous issue that not only Argo CD has, but actually the kubectl is when it tries to apply a very large resource in Kubernetes, and that resource exceeds the amount of annotation size. And that often happens with CRDs while it tries to automatically create the last apply configuration annotation that exceeds the limit. So we get into an error at that point where CRDs can't be applied. So the way, common way a community found to mitigate this, and something that was implemented a while back, is to enable this sync option whenever that is an issue. So Argo CD, instead of applying resources, it will replace. So this is not ideal. Community knows that, and that's why we moved on with this server-side apply feature. Another problem is in some edge cases, Argo CD calculates diffs wrongly. So this is discussed in this ticket. So here it was brought to us in the proposal, the server-side apply proposal, so we could pay attention on this edge case while implementing the server-side apply. So imagine that we have in the cluster this resource, this service, with this 3 entries in the ports. And then someone applies this desired state. So this is what is inside Git. So by the time Argo CD applies this in the cluster, so this is the resulting service. Reason why this happens is because this resource repeats the port, just defining a new protocol, UDP, which apparently is something required for configuring the quick protocol. So this is, something that is required, but once Argo CD tries to apply, so it kind of merges the two ports together. So we have just one port 443 here, and just with the protocol UDP, but what we really wanted is something like that. So this is one of the edge cases. Maybe there are more. This is the one that we are aware of. And this is the use case that was used to validate server-side apply by the time I was working implementing it. So those are the two main issues with the current approach of having resources applied on the client side. And what we are making it available. So end users will be presented with a new sync option, server-side apply. So this sync option is available in the UI as well as, of course, in the application resource. So it will be a matter of checking this box for enabling server-side apply in the entire application. So this is applied at the application level. But if there is an intention to just enable server-side apply for a single resource and not for the entire application for any given reason, there is also a possibility to define this sync option as annotation. So in the resource in question, you just add this annotation, enabling server-side apply, setting it to true, and just that resource will be server-side applied. All right, so let's do a really quick demo I prepared for you. Here I have locally deployed my laptop, Argo CD from master. And as you can see here, it is failing right now. If you click, the reason why it's failing, it's because I'm trying to apply this big CRD, right? And the error message here is basically saying that. So I'm trying to I'm exceeding the size of metadata annotations, and for that reason, Argo CD won't allow me to sync as long as I keep trying to apply it client side. So I'm going to enable server-side apply from the application level. So I'll click Edit and enable server-side apply from the UI. Save. And by the time I sync, yeah, I expect it to be green. So it's green now. And if I click, I can see the message that those two resources, the service and the CRD, are now server-side applied. So this is also something that is going to be visible. Resources that are server-side applied will have this message. As well as here. So this is the other example I was mentioning previously. Here we can see that the service is correctly synced. So we see ports that are from the same with the same port number, but with different protocols. They are preserved because those are applied with server-side apply.
I have a question.
Yeah, go ahead.
What happens to the last applied configuration annotation on that CRD?
In the
Like,
CRD?
yeah. So the reason it fails to apply with client side apply is because that annotation is too large, right?
Yeah, exactly.
So with server side apply, it's that annotation just is gone.
Yeah, it is.
Okay. So then the next question is like, then how does diff calculation um, happen?
Works.
Yeah.
Great question. Basically, then the new so enabling server-side apply is basically a no-brainer when it comes to uh, asking Kubernetes to do it for you. It's a flag you pass to kubectl, and it will do all the heavy weightlifting for you, right?
Mm-hmm.
Why is this a little bit difficult for Argo CD, and why it took a little bit longer for us to implement is because exactly that the current diff logic that Argo CD has wouldn't work with server-side apply enabled. For example, if you have a resource that you apply that resource for the first time, the very first time you apply that resource in the cluster, you apply with server-side apply enabled, last apply configuration annotation is not added at all. So
Mm-hmm.
this would break current Argo CD logic to calculate diffs with three-way merge diffs, because the annotation is not there anymore. If eventually someone, so this is the backward and forward compatibility that Kubernetes implemented. So if eventually someone applies the same resource with client-side apply, then kubectl adds the annotation back to the resource, and then a three-way merge diff can be calculated. But Argo CD can't rely on that, because we can't assume that people will first sync with client-side apply for just later enable server-side apply. So we had to re-implement the diff logic to simulate basically what Kubernetes does in server-side apply in Argo CD. So basically, our Kubernetes leverages a library called structured merge diff, and that same library we use in Argo CD to calculate the diff and simulate what server-side apply does, not based on last applied configuration annotation, but based on managed fields.
Mm.
So basically this. So instead of calculating three-way merge diffs looking at this annotation, it basically looks at this structure here. And this is
Okay.
a richer approach because it allows you to define what are the managers. So we have now defined a specific manager for
Mm-hmm.
the Argo CD controller. So we know that the fields that are calculated, that are used to calculate the diffs with the provided desired behavior, are going to be matching just the fields owned by this manager. And so it allows other managers to live along with Argo CD and yeah, and not having conflicts basically.
Okay. So, and the fact that the managed fields annotation doesn't actually contain like value information doesn't pose a problem in actually presenting the diff. Like this only tells you like what fields are managed, but it doesn't tell you any like values of it. And then, but
There are
the live.
values. There are some values as well. So when it comes to list, so you can see here there you see the port protocol
Hmm,
is also added, but this is like the internal managed field
right.
protocol kind of thing. So this is what they use to make sure lists are correctly merged. But sorry if I interrupted. You're saying about other things about values.
Oh, no, I was just asking that um, we don't need values information here to present an accurate diff because the library itself that we rely on is able to determine that based on the live object, the desired object, and the managed fields, and then the patch that it calculates is accurate.
Exactly,
Okay.
exactly. So basically, I was looking inside Kubernetes source code, see how server-side apply works, and doing something similar in Argo CD
Okay.
to calculate diffs based on
Yeah,
server.
and that's cool that we are able to still calculate that diff client side? Because that was a concern that server side apply might oppose. I thought we might
Yeah,
have to rely on server side diffing, which would cause a lot more API burden,
correct.
API server burden. Cool.
Yeah, I'm not saying it's perfect. Probably we're gonna still find a few bugs here and there.
Mm-hmm.
But as soon as the release candidate is out, it will be great. People start using it. I know ByteDance are already using this feature in their servers because this is something they absolutely need.
Mm-hmm.
They helped us to test and validate things. So yeah, I think most cases it should work. But of course, yeah, there
Mm.
are obviously edge cases that we'll have to work down the line.
So if you're not using server-side apply, does the diff still use the last applied configuration annotation?
Correct.
Okay. So it's only if you turn on server-side apply, you get the new diff.
Exactly.
It seems as if you once you apply it server side, the library actually deletes that annotation, so you actually can no longer rely on. So are you able to infer like, oh, this is a client side apply based on the presence or absence of that annotation, and then decide how to calculate diff accordingly?
According to my tests, no, this is not something you can assume
Oh, okay.
because yeah, our Kubernetes won't remove the annotation if that annotation is there. If
Oh,
the annotation,
did it not do that with the CRD that you?
because it was never there.
Oh, okay, got it. I got it.
Yeah, that's the catchy thing, right?
Uh,
So if you apply for the first time
mm,
a resource using server-side apply, Kubernetes won't be adding that annotation because that annotation is added
yeah,
by kubectl on the client side,
got
right? So
it.
there's nothing at the server side that adds that annotation for you. So that is just added by the time you ask kubectl to apply things on the client side.
Okay, makes sense.
Yeah.
Um, so in the future, let's say client side apply is kind of going by the wayside, and eventually, probably everyone is going to just want to just do server side applies. Um, does that? It seems to me that it implies that Argo CD will need an option in the future to kind of configure, maybe at a global level or system level, to use server side apply, and then we might actually have to provide the opposite flag to say client side apply or
Yeah.
server side apply false is maybe the right.
Mm-hmm.
Yeah, so just probably something in the future that will
Yeah.
need an
Yeah.
option configuration for.
Yeah, it was part of the proposal. It wasn't implemented at this time because
Mm-hmm.
yeah, I agree with you that is something to consider in the future. But there was another kind of a bigger issue to have that at the controller level, is because today we don't have sync options provided at the controller level. So we would require a bigger change to
Mm-hmm.
have this type of setting to be applied at the controller level. But yeah, for something that we're going to be willing to implement by the time server-side apply becomes a most desired sync option. All right. I guess any more questions? Anyone? Okay,
No, it looks yeah good. Thank you, Leo, for the demo and all the explanation.
cool. Thanks, everybody.
Okay. So next on the agenda, Zach has been doing some work on the Open API schema. Zach.
Yeah, let me share my screen here. The window or the whole thing? Um, So I've been spending some time recently working with Customized's support for basically open API schema um strategic patch merging support. Um I'll kind of go over the issue a little bit here. Those that have used Customized pretty extensively kind of pretty quickly run into issues with patching lists on any form of custom resource. The idea being here is if you have this base YAML that defines a rollout, which is a custom resource, and you want to apply a patch, you want to add a new environment variable and change in a variable of something that already exists. By default, what Customize will end up doing, because it doesn't know how to strategically merge lists, it does replacements. And so you end up with basically this mutilated rollout object where you lost basically this keep environment variable. You see the image and stuff got blown away. You lose all these critical pieces of your rollout. I don't know exactly when it happened, but within your customization spec, Customize has added this open API configuration option. There are some pretty I'd say major drawbacks to the current implementation of this, however. So currently what Customize does is they package with the downloaded executable that you get a packaged version of all the native Kubernetes kinds defined within this open API spec, so that strategic merge patches works with your deployments and stateful sets and all the native Kubernetes resources. However, how this is currently implemented is that if you specify your own custom schema here, it's basically a replacement of what comes defined with it. So by doing that, you lose then the ability to do strategic merge patches on native Kubernetes resources, which then, you basically get into the situation where you have to decide, do you want to merge custom resources or merge, the native resources? And if you have mixed in the app, you're kind of out of luck. And then you have to fall back to JSON 6904 patches or whatever they are. And those kind of have a whole bunch of fragile, index arrayed things with them that kind of cause a bunch of problems and complex patches. So with all that said, and the issue explained, I kind of started looking at providing a open API schema that covers all of the Argo projects plus all of the native Kubernetes objects, so that Argo project users can take advantage of Customize in a nice way. And so there's this new. Do you guys see the new repo? I don't know if I shared my window or a tab, or are you guys still looking at the
Yeah,
slide?
we
Or
can see
the
the GitHub
repo?
repo. Yeah.
Okay, cool. So there's this new repo. This is basically where we are storing the schemas for all of our Argo projects plus Customize. There's actions here that will cause this to build at the first of every month and create new tags. So those that want to take advantage of this, you can track the main branch, but I highly suggest pulling in one of the tagged versions. Just because things do change, and basically every month we go update all of the I basically have update all the dependencies for Argo Proj, plus it pulls any of the latest Kubernetes stuff. We do track some of the older Kubernetes APIs, so the native types, like a recent one that changed would be like V1 beta networking for ingress. If that gets removed in Kubernetes 1.2.2, we still maintain schema support in it here, because we pull in a couple of old versions of schemas and merge those in as well, which is kind of nice. So we basically don't track Kubernetes versions, we track Kubernetes API versions. And And then there's a pretty decent blog write-up that I did on Argo project, kind of goes into a little bit more detail on how this file was generated, and some of the issues that are happening upstream to kind of help make this a little better for end users. There's basically two major spots where upstream support can happen. I know Customize is working on trying to basically make this an addition, so that you can add your own and then they will figure out how to merge it together and do that. That would be a pretty good step in the right direction. And then there's also talk about upstream Kubernetes adding the ability to define, or adding the ability to define the extra metadata for merge key support within the CRDs themselves, and keeping them so that when you do Kubernetes fetch OpenAPI spec, you'll actually get the merge keys down there for custom resources and not just the native kinds. They kind of play a little bit, they get a little bit special treatment, being a native a kind currently. So yeah, that's kind of all I had. You know, you want to take advantage of Customize in any Argo project. This works for rollouts, CD events and workflows. Argo CD, there's an open PR still that I need to finish up to add the merge key information to lists. But all the other ones have those already, so they should work. It's pretty easy to use. You can just, you know, provide a URL to you know, the schema there, and it's kind of all explained in the blog post as well, and we'll update some documentation to each of the projects. But yeah, I suggest also using, you know, tagged releases instead of the main branches. But yeah, if you guys have any questions.
So I guess generally speaking, it's probably safe to just kind of pull the current versions of the APIs, because this is based on the assumption that Kubernetes upstream generally doesn't remove fields, like for a long while, even after they're deprecated. And then same is mostly true with the Argo projects. We tend to kind of leave around the old fields in case they and at least let them exist, even if they're being ignored.
Yep.
Is that safe to say that we can?
Yeah, it's fairly safe. So basically, you know, especially with, so like you can look at some of the commits that happened here recently. You know, generally any breaking change is going to require a new like API version, right?
Mhm.
And so, and I think Kubernetes and both the Argo projects are pretty good about either not making breaking changes, and or if they do, putting them under new versions. So you'll see things that, you know, like descriptions and stuff and fields will get changed. I thought there was one of these where we updated some fields within workflows or added some new things in workflows, and that's generally a fine thing to pull in. The only area of risk and why I would say is to do a tag instead of following mainline is within, so I should actually probably document this somewhere. Within within this, what do I do that? There's basically a handful of what's it called? Kubernetes versions that basically we look at for, we basically download the Kubernetes version schema.
Mhm.
And if for whatever reason, let's say we, you know, we're pulling Kubernetes 1.9, 2.0, and 2.1, and then we're following the latest from there on out, right? So if Kubernetes were to remove a particular API version from the SDK, that
Mhm.
would pull it from this, unless we specifically added that version as a, you know, a keep tracker kind of, right?
Mhm.
So that's the only small risk about following
I see.
like
So you're saying
mainline.
like
So yeah, here's the version
when
that we pull.
you're saying like, so when Kubernetes says HPA v2 is the default, and then we're no longer serving HPA, v1. That's the point in time that users will have to kind of carefully check to make sure it's safe to upgrade to the new schema.
Yeah, that they're using the new schema exactly, and so if Kubernetes ever were to remove HPA v1 from the Golang SDK, not even serving, like we don't really care what happens at the Kubernetes API server running
Oh,
level,
I
right?
see. Okay.
We only care about the library. So basically, if Kubernetes Golang SDK removes,
Oh,
that,
okay. Which
then
is
that's when
actually
which I don't
that's
think they
actually a
ever do.
safe. Yeah.
Yeah, it's pretty safe, right? Like I don't think they really get rid of them from the SDKs.
Yeah.
So that would be the risk. And so currently, like in this, I pull 18, so 1.18, 1.21, 1.24,
Mm,
and then the latest. So 125 got released. So basically it'll pull 125, and if 126 gets released, it'll automatically pull 126, and it'll keep doing that. And as time moves on, we might add another,
mm.
keep history type version thing. But yeah, other than that, it should be pretty safe to follow either master or some tagged release, which happens
Okay.
monthly.
And so those 18, 21, 24 have significance because the following release is actually when the SDK had removed some.
Nope,
Uh,
nope. I just picked some bigger releases where they deprecated a bunch of things to keep them.
mm,
Because basically, if let me go find that file. Where is that? So there's a file in this here. There's a file in upstream Kubernetes. So these files here it's basically, this is the definition of all the Kubernetes native resources with their merge key information. And I talked about this in the blog too a bit. That when we pull down, when we generate the Kubernetes definition, we don't have the 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 way that the open API generation auto generation code works for Kubernetes. It doesn't actually include merge key. It doesn't actually include this merge key information in the generation code.
mm,
We can get this information from Argo project stuff by easily inferring it.
mhm,
However, upstream, if I generate basically this exact file missing this information, and just it doesn't have this information from the libs, so I download this version of it, and I'm able to match the dictionary key that this is in to pull this merge key information.
mm.
And apply it to the new generated one that we generate with all the stuff in it. So upstream, if they add, what's this definition? This is mutating webhook, right?
Yeah, yeah.
So for v1, so if this were to, if they were to change, add a new version or whatever, and this were to disappear from this, I would need the old version still to generate the whole matching set, right?
Mm.
I know that's really complicated, and this whole thing was kind of complicated, but does that kind of make sense?
Yeah, yeah.
Okay. But it does work well. We're using it internally within Intuit to do, custom mergers of rollout objects and stuff like that. It's the only project I've seen that supplies open
Mhm.
API schema definitions for their end users for customize. I think it's a little bit of a mess upstream. So
Yeah. Yeah. Um, yeah, no, thanks for explaining it. Again, I thought it'd be useful to kind of talk about it some more and get it recorded
yeah.
and get the word out
Yep.
about
Yep. And if people are really interested, I definitely recommend reading the blog post. It goes into a little more details on kind of some of the issues that were worked around, I guess.
Okay. Any questions about this before we wrap up? I didn't see any other agenda item topics, so I think this is the last item on the list. Okay, so I think that concludes this month's Argo CD and Rollouts community meeting. And last reminder about ArgoCon in 2 weeks. It's not too late to sign up, and we'll see you then. Thanks, everyone.
Later.
Thank you. Thanks, everybody.